All right, we are asked to find the radius of convergence for the series, so that's definitely the ratio test, right? That means that our end game is to have something that looks like this. X minus a is less than r, and that r is my radius. So I'm going to go ahead and do the ratio test, the limit as n approaches infinity of the absolute value of x minus 4. I'm going to plug in n plus 1, so this will be 2 times the quantity n plus 1 over a 3 to the n plus 1, all over this x minus 4 to the 2n over a 3 to the n. Okay, cool. And we want that to be less than 1. So let's clean this up a little bit. Again, it's definitely not cheating if you're able to flip a lot of this stuff pretty easily. So this is the thing that's going to get flipped, right? So I'm going to get a 3 to the n. The 3 to the n plus 1 will be on the bottom. On the top, I'm going to have an x minus 4 to the 2n plus 2. On the bottom, I'm going to have an x minus 4 to the 2n. It's less than 1, right? So these guys cancel. So here's my limit as n approaches infinity. These guys cancel to give me a 1/3, right? These guys cancel to give me an x minus 4 to the second. And now I suddenly don't need the limit anymore because there's literally nowhere to plug in the n. So I'm going to get this thing inside a squared is less than, when I multiply the 3 over, I get a 3. Well, now I need to square root, so I'm going to get x minus 4 is less than, and it's just going to be the positive version of the square root because can't be less than a negative square root of 3. Like, that's not possible. Like, a positive or 0 number can't be less than the negative square root of 3. So that's going to be my radius, right? Because this is x minus a in an absolute value is less than r. That's my radius. I'm looking for root 3, which is answer C.